So
Yes,
thanks everyone for attending today. I know it's not very easy attending a meetup after work, especially on a Thursday, but I'm hoping that I can give you an idea of what observability looks like in practice. I'm not going to talk about the breadth and depth of observability concepts and the practice behind it. I'm going to talk about more about the observability at Cinch. Hopefully you can take some of these ideas and concepts to your day job and adapt them to your problem domain. That's my goal. First of all, I'm Toli. I'm a software engineer with a background in mathematics. I like to say that I learned to write code the hard way by being given some code and to build software to solve difficult optimization problems. And I've since worked across a few industries, all software stacks and many programming paradigms, both on-prem and in the cloud. So that's me. In the last 3 or 4 years, I have a spiked interest in DevOps and observability practices, and especially how I can empower teams to embrace these practices so that they can excel at their goals. At my current role, I'm quite lucky as a principal practice engineer at Cinch. I have the opportunity to put this interest into practice at an exponentially scaling organization. If you were wondering, Cinch is a car buying platform that promises to take the faff out of finding, buying, and owning a used car. And to save you searching, in case you don't know, the informal definition of cinch is something easy. So if you're referring to an easy problem, you could say the problem is a cinch. So why did we focus so much on observability? How did this shape our organization and engineering practice? And what did we learn through this process? It makes sense to take a step back. It's worth talking through the highlights of our tech stack, as indicated from the title that I've given to this talk. We are entirely serverless. We use AWS Lambda as our kind of unit of compute, if you like, and all the AWS serverless services around AWS Lambda. We are entirely TypeScript from the front end to the back end to the infrastructure. We use AWS CDK for our infrastructure. And the only thing that's probably not TypeScript, although I wouldn't be surprised if it is in the near future, is our pipelines, for which we use GitHub Actions workflows in YAML, and our source control is in GitHub. And Datadog is and most importantly, Datadog is our observability and monitoring platform of choice. That's our tech stack highlights, and it's worth having that context. In terms of our engineering principles, we chose serverless, which in itself forces down the roots of event-driven architectures. I'll explain what this means in a bit, but if anything, it helps us build resilient systems and enhance team autonomy. We have no QAs at Cinch, so since we wanted to move at pace, we encouraged engineers to really think about how they can automate testing as much as possible to ensure good quality continuous software delivery. And talking about continuous delivery, we recognize that moving in small iterative changes would minimize risk and encourage a lean approach to software delivery. We highly discourage big bangs. And finally, flow and feedback are inherently interlinked. We decided that from the start we wanted to build observable systems. To be a true DevOps organization, we settled on the build it, ship it, support it model, which is slightly different to you build it, you run it, in the sense that it emphasizes a bit that there's part of it that you ship as well, and serverless makes it a lot easier to ship. So in this model, squads take ownership of the entire lifecycle of their code. So since we were good at building and shipping, or we found out that we were good, or we got good, we were slightly immature in supporting, and that is in line with what we're seeing in the industry. So in when we started thinking about Cinch as an idea around about the start of 2019, and we were reading the excellent Accelerate book and the Dora research, the industry has advanced. An organization that was elite in terms of DevOps maturity in 2018 was only 7% of the total organizations that was part of the research. As per the latest State of DevOps report, which was published in September 2021, 26% of organizations are elite in terms of software delivery performance. Another important aspect that was seen in the industry is that although software delivery is measured by the 4 metrics, 2 indicating speed, which are the lead time for changes and deployment frequency, and 2 indicating quality, time to restore service and change failure rate, there's a 5th metric, reliability, that measures operational performance. And this 5th metric indicates organizations that at varying levels of maturity that actually perform better by having more reliable systems. Having chosen serverless, we didn't do badly, of course. We had a lot of benefit from the kind of auto-scaling, just having an auto-scaling system that we didn't need to care about any servers or containers or anything. Our first full week in prod, our production AWS account cost was less than our dev account, despite the sudden very high traffic that we have, as you may have seen the TV adverts. The high traffic reduced the cold starts and serverless scaled beautifully. It was actually a beauty to see and experience. This graph displays the traffic our first 5 days going live. So in the top graph, you'll see the spikes, the three massive traffic spikes that we have. In the bottom graph, around about the same time, you see the P99 latency of our APIs dropped significantly due to the drop of cold starts. Serverless was working and has worked for us. But are our production services delivering on their promises consistently? And this is a question that we tried to answer with observability. To start with, just because I'm going to mention it a bit in this talk, I'll present you with Cinch Brew. We're not selling coffee yet, but Cinch Brew is a fictional software system demonstrating good observability. So the system designed is with common cinch architectural patterns in mind, and it's used as an observability blueprint, if you like. I said I was going to mention a little bit about serverless. Serverless architecture omits any concerns for where your code is deployed. You can imagine it as a blank box within which you put your little bits of code. And then you glue them together utilizing cloud serverless services, whether that's an API that you put in front of your little bit of code, or it's an event bus that your little bit of code subscribes to the event, to the bus, or you publish one to the bus, or you have a dead letter queue, or any databases that you utilize straight from the cloud. If we were to see a simple system, which is the Cinch Brew, the little disk on the left is our front end, and the little disk on the right with the F is our Lambda function, so our backend. And if we were to put this in production, we get a very, very simple, very straightforward front end Cinch Brew requesting something from the backend Cinch Brew order component, probably ordering some coffee. And on each of these rectangles, you see your top level metrics, your errors, your latency, your requests. Pretty simple, pretty straightforward. You get a good idea of what's going on. Then if you take this into a bit more context, this box that I've emphasized here is a bit more complex, but kind of the same paradigm of a Lambda and a front end. But then there's all the rest down here, which is also architectural patterns that we use at Cinch. So as you can see, if you take these type of patterns and you multiply them by loads of teams producing serverless services or serverless components, as we call them at Cinch, you end up with something like this. And this is our actual production system across all our teams and all our services, and you can see easily how they interact. And I'm joking, you can't really see what's going on, and I'm hoping that you can see the complexity creeping in from something very simple, put your little bit of code, glue them together, and you're done, to something quite complex. So going back to the concept of reliability. Reliability is an outcome of a series of things. So serverless does provide some reliability out of the box, as we saw from the graph, the graph of our first week of launch. Good software delivery practices and good architectural design contribute as well. But since we had chosen serverless, what we could focus on is improving our observability and monitoring. We needed to know when something breaks and more importantly, why. We also need to know how well our services are performing against the business promises we had made. This is something we didn't know at the time. By the way, notice the abbreviation. I don't know if I mentioned it in other slides, but you can also use OLI for observability here. I'm not going to delve into a definition of observability. I promise I won't. But the one thing I'd say in terms of definition is that observability is not a practice. It's a property of a software system. And it's a borrowed term from control theory. And really what it means is how well can you understand your software system from the outside? Honeycomb CEO Charity Majors, I think, as far as I know, coined the term. And I would highly encourage anyone interested in delving deep into observability to look up Charity's blog posts or even her rants on Twitter. I've linked here a representative example of how well, of a well worth reading blog post. I'd say a lot of the things that I learned about observability, I learned from Charity. Very early on, our leaders at the time at Cinch had this vision of having a highly observable system, and we're also inspired by Charity. What I would say, though, is that, and it's a learning that we've had at Cinch, is that observable systems are built and improved by teams that routinely follow good observability practices. It's not an individual and it's not a separate ops team. It's the teams themselves who write the software. The first big aha moment with observability is to understand the concept of instrumentation. Don't just log free text. Think about what and how you can configure your code base so that you end up with a rich telemetry data set. That's a bit vague, I know, but that's the first kind of pivot, that's the first mental pivot that you need to make to on your observability journey. The next thing is, I'm not talking about the old drop an agent on a server and let it collect metrics, because that doesn't work, especially in serverless. This goes beyond automation. There is a practice of custom instrumentation that elevates observability of your systems. Although automation does take you a long way. Thirdly, we're all familiar with logs and possibly metrics too, and that's only 2 out of the 4 boxes that I've added here. But for high observable systems, it's traces and RUM events that really make the difference. I'll talk a little bit about what RUM events are in a bit. But in our case, trace metrics and logs are for our lambdas, our backend, and RUM events for the front end. By the way, just in case you end up going to Charity Majors rabbit hole and then you say, well, that's not actually what Charity Majors advocates for, because you won't quite get this story. But I won't get into this unless you want to talk about it at the end. As evident from the focus on tracing and RUM events, logs are not our answer to more observability. We use logs a bit more sparingly, but they still have their place, in many cases, alongside traces and RUM events in the same point of the execution path of the Lambda function. Being able to pivot between traces and logs both ways has offered that pathway for teams and engineers to utilize traces. Remember that logs are familiar and traces are scary, and observability is a journey. We have also found that the free text nature of logs are familiar for non-engineers. Product owners, business analysts, etc., can make sense of these on dashboards. An example of logging is the logs of our communication component. Someone can easily read the list of 3 logs: handling application improved event, sending application improved email to customer IO, successfully sent email to customer IO. It tells you what is happening, but not quite the how and where. You can't really drill into it, or even what is happening around it. However, it's still valuable. You have the bonus of getting aggregations through in a widget like this. And then we come to traces. Lambda functions are inherently event-driven. Therefore, tracing each invocation and adding custom instrumentation provides deep context and traceability. You can quickly know the what, the why, and what is happening around a particular invocation. I'll show you a code alert here. I'll show you a little bit of code just to show how you go from the instrumentation of the code to the UI. You can actually configure the Lambda with auto-instrumentation. So what that means is we use AWS CDK to provision our Lambdas, and this is a data CDK construct that we use to configure our Lambdas, and it's line 153 that makes it makes this list coffee bean types Lambda auto-instrumented by adding it to this array of Lambda functions. That's all, and by doing that, with your Lambda configured, magic happens around your Lambda runtime that allows for telemetry data such as traces, logs, and metrics to reach Datadog. I know this may be a bit of a complex diagram to just look at quickly, but ultimately this top bit refers to how your Lambda is enhanced via layers and extensions, which I won't get into here, to be able to send telemetry data seamlessly to Datadog. And then that's for a little bit of code that I was referring to earlier. Your Lambdas are the little bit of code that you write and you care about. And you can also get logs for your cloud services that you utilize around your Lambda. And that completes the telemetry data set in the back end. So by just doing this auto-instrumentation, you suddenly have a very rich telemetry data set that you can use for various visualizations. So I'm going to go through some of the visualizations, and with the danger of giving you a bit of a Datadog demo. But what I want to highlight is how just from that simple configuration, you can get to many different presentation layers of your backend. So this, you can see your trace map. Cinch brew is the front end, and cinch brew order component is our back end. And you can see that this is quite simple, but if you have a more complex architecture, it becomes more interesting. You also get some top level metrics, your typical red metrics, requests, errors, latency, which helps with understanding the kind of what's going on with your Lambdas. And you also get an interesting evolution of the tooling around here, around serverless, is that you can get a service stack overview. What that means is that you can get an overview in Datadog and the observability tool of all your, or most of your AWS resources that are in your stack. And in this case, you get your Lambda function with the top level metrics again, invocations, duration, errors, throttles, which is the Lambda serverless specific metric, and you get your API gateway, which is your cloud service that you use to glue together your Lambda functions. You can then drill into further and look at a particular Lambda in your stack and get things like your duration, concurrent execution, or other top level metrics, and look through the various invocations that happened in the last hour, for example, and their top level metrics, and then click through to their traces, and it just goes on and on. There's a lot of depth to this. And finally, you can get to this data set. This is, I think, the core of where telemetry and observability happens. Span is a term in the observability and telemetry space, which at Cinch people I've heard me talk about a lot and probably got fed up of talking about it. I don't have a great way to describe it. If you think of a particular request from the front end to the back end as a story, then a span is kind of the parts of that story, the stages of that story that accumulate to the story, and that's kind of your unit which you're able to gain context from and aggregate across. So these top two rows are both spans. So we've got two spans here. One refers to cinch brew, which is our front end. The other one refers to cinch brew order component, which is our back end. You also get visualizations of your duration. So it took about 2.2 seconds on the front end and 300 milliseconds on the back end. And you can flip that with something called the flame graph, and you can view this in this graph that where the top rectangle is our front end again, coffee. The URL coffee types, and this is a different actual invocation, so the numbers might be a bit different, but you get the idea for different visualization. And then you can go further and further. I'm going to whiz through these things just so that I don't become a Datadog demo here, but you can do aggregations, and there's a lot of power in doing aggregations, whether that's time series, whether it's a top list, or as a table. But as I mentioned earlier, with instrumentation, you have auto-instrumentation and custom instrumentation. What I would say is that custom instrumentation is where the difference is made. As an example, going back to some code, this is a Lambda handler that responds to an API gateway event. Line 9 is where a custom tag is added called response hard-coded. This is just an example tag, and it's set to false. And that line is then visualized in the front end of your observability tool by inspecting that particular span or invocation, or however you want to call it. And then this can be aggregated across other spans. So it makes your telemetry data set a lot richer and a lot more custom to your problem domain. Telemetry and observability at Cinch, at least, is not only about traces and logs. From day one of moving to serverless and AWS, our Lambda functions have been emitting custom metrics, for example, order completed or finance application started, which really help us have deep understanding of the performance of our service in terms of its business objectives. Deciding when to use these to get key insights in our business metrics from the ops perspective is key. Another example from the same code that I showed earlier, line 9 is the one that I showed in a couple of slides ago. And line 16 here is an example of sending a metric, available coffee bean types and the length of coffee bean types, which is a value that's from the database directly. And this is used to aggregate, again, in the UI. It's something that the team might care about. We want to know what type of coffee exists at any point in time. We don't know what question we want to ask, but we have that data available. And we can query across time, again, with either time series or using a little widget with a query value. And there's a lot more other analytics you can do, but I won't delve into this, so I don't, because there's a lot of richness. Finally, squads that have ownership of the front end inevitably upgrade their front end observability by utilizing RUM events extensively. RUM stands for real user monitoring and gives you end-to-end visibility into the real-time activity and experience of individual users. Our front ends are automatically instrumented as we did with traces, with extremely rich data, but we also instrument with intent. So we also use custom instrumentation. RUM events have definitely helped onboard front engineers on the observability train and understanding the difference between instrumentation and simply logging free text. Again, an example of auto-instrumentation here is using the browser run client offered by Datadog, which is we're setting our service on line 7 to cinch brew, and we're doing all the configurations needed to auto-instrument. And as a result, by just that configuration in our website, we get very, very useful analytics and performance. Again, we don't know what question we want to ask, but we have the data there to use, and that's whether that's core web vitals, which are used for Google ranking, or it's just listing the most viewed pages and various performance metrics, top level performance metrics. A very important feature that we kind of milestone that we reached is that we've linked our front end to a backend. So although so far I've been talking about RUM events and traces being two separate things, now we can link the two, which means that you have a request from the front end and that goes all the way to the back end to the database, and you get all of that context in one place. And that's very powerful in many ways, and it even kind of joins up the front-end minded people, the back-end minded engineers, and gives one view and emphasize this kind of T-shaped engineer that we talk about at Cinch. And you can see what's interesting is that you can get statistics like, it took about 2.2 seconds again on the front end, and the back end took about 300 milliseconds. So the front end took about 86% of the time. Finally, again, like traces, you can list RUM events in a similar way, and you can graph them. So again, emphasizing this importance of having a telemetry data set or a list of telemetry events that you can then aggregate in many ways after that. Again, as with tracing, custom instrumentation makes a difference here. So as an example here, we can add a custom action. So user is sleeping, so user hasn't done anything for a bit. That's a 5 seconds inactivity. We log that, and we're able to query that on the Datadog UI. Or you might want to set a user ID every time someone logs in, so you have that granularity of then finally on the Datadog UI aggregate across user IDs. So here you see a graph of a time series of views on the website, and you can group by user ID, and you can get a time series, and you can get all sorts of interesting insights. That, again, questions that you might not know what you want to ask now, you can ask them in the future. Since we are at Devs Connect, and we kind of, it's more about sharing learnings. It's interesting to share some of the things that we did learn, more of the positives to start with. So use traces and run events as a rich data set of events. That's definitely something that we tried to achieve. We learned that using the trace and claim graphs is less useful than being able to create a data set of spans or run events. Adopt custom instrumentation practices, so don't just focus on auto-instrumentation and forget about everything. Consistency across the various telemetry data sets. What I'll call out here specifically is the service boundaries. We found that defining a single service that encompasses all the related Lambda functions increases clarity and even helps with architectural design sometimes. As a last thing, we found that when we actually followed the tool's principles, Datadog in our case, our adoption and effectiveness of using the tool grew dramatically. So what I mean here is that although we might, my mental model of observability might be everything in this event, and you should view your telemetry events as simply events rather than having various different telemetry data types. That's not how our observability tool is built. And going against that would cause us more confusion rather than using the tool effectively for better observability. Challenges worth calling out. If you're looking to implement observability where you work, be aware that engineers are used to logs. All the extra data types, metrics, traces, run events do cause confusion and require substantial efforts to shift the mindset to a more holistic mental model of telemetry data. Engineers often have to see traces or even run events work to discover their value. And finally, we had another 3 challenges worth mentioning is that initially we kind of had a mix of AWS X-Ray SDK, which is AWS native tracing product, and Datadog SDKs, and we still have that to an extent. And used together, they're quite confusing, and most engineers don't understand the subtle differences in concept standards and naming conventions, nor should they care, as in my opinion. We definitely ended up overusing metrics. Although they form powerful signals, we often lost the context of the why. And finally, getting everything right at once is impossible. It really is a matter of continuous improvement. So that's the instrumentation part of observability. There's a lot of things, and it's a rich topic to cover, but I thought I'd finish with some really nice concepts and practice around dashboards that we developed over time. So in parallel with all our instrumentation practices, it was evident that each squad, each team would have to create and evolve their own dashboards. Engineers who build the services know them best, so we empowered them to create simple and insightful dashboards. We made an important point, of course, not to dashboard gaze. Squads would create dashboards that give them a snapshot of their domain telemetry data that they produced with all the instrumentation practices that we just talked about, to get important signals from production. They created the so-called stand-up dashboards that allow them to use the dashboards as focal points at stand-ups. Some dashboards are even used almost as an entry point for everything related to their squad, with links to all squad information. And with that, I'll give you some examples of dashboards that I picked from across Cinch, and some of the people who have created these dashboards might be at this talk as well. This dashboard, I find it incredibly inclusive. I love the name of it, motherboard as well. And all the questions, I really like this. I got really excited when I saw it, because each section of this dashboard has got a number of widgets in it. And if you collapse it, you can see the widgets. But if you see it like this, you see all the question, or you see a question. So that question helps you to understand what the widgets within it try to answer. So coming to this as a user of this dashboard, almost, it shows you how to use it. So our order is looking healthy. Is our part exchange service healthy? Are we seeing errors? Do we have an instance? That helps new starters. It helps people outside the squad to come and look at this dashboard. I absolutely think it's brilliant. And another example of a comprehensive dashboard, or maybe like an entry point, like I mentioned earlier, is this one, where the top level of this, the top part of this dashboard has all the links that are related to this team. This team looks after the search part of the website, the searching vehicles. And as a new starter, as a member of the team, or someone outside the team or part of the tribe, you might come here and you can find all the links that are related to the squad. And at the same time, just below it, you have health at a glance. So you have all the kind of metrics that the squad thinks are valuable for you to know. How is this part of the website doing? Is it doing well? And just getting that at a glance. Finally, there's a couple of dashboards that are really customer centric. And this one, for example, is for the payments and invoicing team. That they really focused on surfacing the important information that they had, the important telemetry data that they had around the usage of single cards and multiple cards. Just for context, multiple cards are a unique feature that Cinch has around paying for a car. When you're paying for a car outright, you can pay with multiple cards. And if you try to buy a car with outright without finance, you understand how useful that is, because banks have limits per day as to how much you can pay on a card, and this helps massively. I'm sure that in the next talk, maybe the next speaker might have an idea of how to solve that with their product, but this really helped us. And actually, the team itself, the team who built this feature, knows exactly what percentage of multiple cards is used as opposed to single cards, and how many people are actually using it. So really close to the customer. And finally, the search squad again has a section on traffic at a glance. I really like this because it has this funnel conversion, this idea that you have this journey from finding a vehicle to actually checking out, and this very analytics focused concept being right in front of the team day to day, and it's something that they measure, they know about, they talk about, as well as all the kind of top lists around model searches and make searches that you can find here. I find it very user centric, and I credit Andy Norton for this screenshot. We built our observable systems by performing what you can call a collective cognitive load shift, from servers and containers to observability and monitoring. Our teams looked after our software, and they look at our teams look after our software, and they do it really well. I promised to kind of demonstrate what observability looks like in a serverless architecture, why we kind of emphasize so much on observability. It's time to kind of talk to you a little bit about why this was important. What were the wins? So although serverless enabled us to focus on production, despite our initial challenges, ultimately focusing on delivering value to customers, we distributed the responsibility to the squads. So they are leading the way. We don't have a team that leads the way on this. It's the squads themselves who are building the systems. We achieved fast flow with short and immediate feedback loops, and we became truly experimentation-led. We saw some emergent practices. Technical change to achieve higher observability does not take place without creating or evolving squads practices. So we started from very basic practices, and we came out with some very interesting and intriguing ways of working. So many common practices naturally emerged once the squads were given the task to mature their support of their slice of the production systems. One thing I would call out here is the practice of regularly reviewing dashboards daily during stand-ups or even stand-downs at the end of the day. Another one is weekly to identify improvements so that observability and monitoring patterns and practices don't stay static. As a result, major incidents are a very small percentage of our deployments prod. And this is a very, very important aspect. We don't shy away from incidents. We don't think incidents are inherently bad, but we, by moving fast and in small batches, the percentage of failed deployments has actually gone down as the number of our deployments increased. And just to give an overview of kind of where we started and where we are now, a year after our initial launch, we continue to deliver at pace with true observability at the core of engineering practices. If I had to summarize it, serverless freed up a chunk of our squad's cognitive load. It introduced new engineering practices and patterns as a byproduct, but it really did focus efforts on an enhanced DevOps mindset and allowed us to achieve, to actively improve the observability of our systems. In terms of where we're going next, initiating a facility community of practice around DevOps and observability to support our efforts as we scale. Have some principal engineers around teams to support the squad's efforts. And in terms of actual implementations, one direction we might go down is create good SLOs that might replace some monitors. Monitor fatigue is a real issue, and you end up creating too many monitors in the telemetry data set. Establish and evolve good observability blueprints, as you've seen the example of cinch brew. That's an implementation of that. We have found the hard way how tedious incident management can be, so we'll be looking into tooling and more chaos days to improve. We'll also be looking to expand on our capabilities by including CI/CD observability. Quality, deployment frequency, and lead time should be at the forefront of all our squads. And I know for a fact that a lot of our squads are thinking about, if their deployments are about 20 minutes or 10 minutes, they want to halve that if possible. We want to find any way possible to do that. We'll probably find ourselves also applying the same collective cognitive load shift to security quite soon. To wrap up, if I had to summarize the driving forces behind our journey to true DevOps and high observability in the serverless world, that would be: choose your tech stack wisely. If Kubernetes offers the collective cognitive load shift towards observability, that's cool. For us, it was serverless. Choose engineering principles that achieve continuous flow and feedback. And give ownership to your teams, trust them, and let them fly. My takeaway message would be patient with DevOps and observability. Continuously delivering and supporting and operating production systems do not come easy for software engineers. Support them, particularly when you're growing entirely remotely. And I think with that, I'm done. Thank you very much for listening. And if you want to get in touch, I've got a personal email address, work, or on Twitter. Feel free to reach out. Happily reply.
Thanks, Toli. Great talk. Thanks very much for that. We've got some questions if you're okay to take some.
Yeah, brilliant.
So let's go through in upvoted order. How would you suggest to seed the idea and practices of observability at a company?
Very good question. Start by crying, because observability is not something that is really on the forefront of even engineers. So I don't know if the question relates to the leadership of the company or the engineers itself. If you don't have buy-in from the leadership, we had loads of buy-in. They initiated the idea at the very start, so that was easy. The hardest bit for us was to see the idea and the practice of observability, and that comes with time. I think I can only say what we did, which is make sure that we talk about observability a lot, share our knowledge. We watched a couple of videos of charity majors. We implemented some simple instrumentations. We set up all the architecture. It's important to make it easy for teams and engineers to actually instrument their code. The moment they have to do extra work, they start doubting whether it's worth doing. So it really does come over time, and it depends on the scale of your organization. But I think you need to have people in place to advocate and help their fellow engineers to actually learn and introduce these practices. So one thing that we did, just to demonstrate this, is that we had a role in each team called the automation engineer that helped upskill their teams around anything around infrastructure deployments and observability. And in fact, most of their time is focused on observability because it's something new for most engineers. And because they're embedded in the teams, they know what problems the team needs solving. So I think that helped a lot.
Thanks for that. Next question we got is, do you advocate for keeping all logs, metrics and traces forever? So is that something you advocate?
Even if you wanted to, you can't keep them forever, I guess, unless you put significant effort into it. The value of metrics is that they stick around for a long time. The value, and they're high level signals. The value of traces and logs is that they're more high granularity, so you can dig quite deep. So you probably want that type of information in like the last month or so. You probably don't want it later on. So the metrics you probably do, at least in the Datadog mental model. That's how they've modeled their software. The metrics are there for about 15 months. So that probably does work. They've started offering services around cloud warehouses that you can use to query things when you need to. But we're still young, so we haven't really gone past the 1.5 year threshold to think about whether we need things for a long time.
It makes sense. It depends on your use case, I guess, as well, doesn't it? What you're using it for, and you'd probably be putting some implementation of some sort of audit feature if you really needed to keep that data around. If you really need that, it's probably something beyond what observability is generally for, isn't it? If you're keeping it long term.
Yeah.
Next one's, I notice a user's name logged here. How do you manage personal information, privacy, GDPR, etc.?
Yeah, I meant to mention that cinch brew is in a fictional software system. So we use identifiers that obfuscate the user details. So wherever we use telemetry data, we use identifiers like finance ID or user ID. We never use personal details. And in fact, there's tooling around masking and filtering out any sensitive data, both in Datadog and in any other systems we use. We have quite an elaborate serverless GDPR removal tool that helps even if things get in, because then you can get them out quite easily. So yeah, there's tooling in Datadog to, by default, not have personal information. If things, you can do it at the entry point of the data, I guess.
Yeah, so you've got guidance on the way the teams build these things out, the way that they're logging and trace information.
Yeah.
Next one is
and in fact, I guess just on that point, the personal information is less, like the name and the surname is probably less queryable than the ID. So the ID is more useful anyway. So in fact, for observability, you only really need the IDs. Yeah,
so most of what you do is tied to around transactions rather than specifically having to identify a user from their personal data anyway. So how, if at all, do you account for the act of instrumentation affecting the metrics? So I guess has the instrumentation gone in the way of the metrics? Has it coloured the information? Have you found that so far?
Do you mean here performance metrics?
if anybody wants to unmute themselves and ask a bit more, feel free to chip in. If not, let's assume so. Let's think about it. Presumably they're talking about performance metrics and timing.
It's interesting because we were looking at that today. We were kind of trying to figure out whether one pattern that we're using was impacting the serverless invocation in terms of performance, and it was very, very minimal, if anything. We haven't had any evidence of that, especially because of the architecture of using the layers and the Lambda extensions now. The Lambda runtime has exposed a lot of kind of ins into the life cycle of the Lambda, so that I think that's made things a lot better in terms of performance than they used to be. I think the answer is we used to have issues with Lambda. I don't think we have any more significant issues.
Yes, it's not been a big concern. Certainly not anymore with what you're using. Again, on these, feel free to interact with these. If you want to chip in on the questions and elaborate at all, or if you want to respond or share your own experiences, please do. It doesn't have to be a one-way street. Feel free to chip in.
Yeah, well, the Accelerate book, that's probably opening a rabbit hole if I start talking about the books that I'm interested in. But I guess team topologies is another big one, and that's helped me. It's not observability specific, but it's given me a big insight into how to think about communication. And I guess the other, there's a book that Charity Majors and Liz have been writing on observability, which is on my list to read. I think that I'd suggest that one because it's more like a handbook type book. And obviously the DevOps handbook is another one to call out. I'll stop there because I probably can talk about books for a while.
Okay, next one down is observability seems like only half the solution. How do you ensure that the insights are actionable, particularly in a serverless environment? Yeah,
I mean that's a great question. An interesting scenario that I heard recently from one of the teams is that as part of the stand, that I was kind of talking about how useful stand downs have been, and stand down is where they just get together just before 5 and before they log off, and they check that everything is as expected, because what happens in the evening until the next morning, if there's something that there's an issue, it's better to find it at that point and hand over to on-call people or solve the problem if they can quickly. The example there was that at stand-ups, when you look at whether there's an issue or not and you find one, they kind of assign someone, this looks a bit odd, can you go and have a look? And at the end of the day, they report back and say, oh, well, we found that it wasn't anything, or it was something, we fixed it, or we found a performance improvement, or we got this insight. The loop kind of closes, it seems. And just to know on that, it's not something that we've mandated. This kind of naturally happens when you ask people to look after production systems, because developers and engineers, they engineer the way they work so that it can be effective. And they've come up with all these creative solutions that are quite amazing. So I feel like it's more about motivating and giving responsibility rather than prescribing what to do and when.
So a lot of it, the way you're working at Cinch, teams are owning their changes from end to end.
Yeah, deployed to production. They look after, they follow through. Well, typically you would follow through the production deployment, or you would know at any point in time whether, because of your observability and monitoring maturity, you would know if something was not going quite well, because you know what you care about, and you've written the software, so you've got a better feel of what's looking good and whatnot. Because that's a big thing, that it's hard to know, is the software doing what you're expecting to do? We all pretend that we think we know, but we don't really. So the best approximation is done by the people who wrote the software.
Great, and a continual learning loop, like you were saying about closing the loop off. So you're learning from any mistakes. If something takes too long to diagnose, you're looking at how you can improve that for the next iteration. Who has access to these metrics? Do you use it for anything else but monitoring?
All this data is primarily operational, but it is leaking into things like CI/CD metrics to improve your deployments and your testing. It is leaking into analytics. It's leaking into general understanding of how green our system is, because our kind of people looking after instance might look at some of the dashboards. So it's leaking into various other areas, mainly because the data is so good. I think is evolving and it's maturing, and people can trust it, and therefore they can gain insights from them. So I think it's a very interesting question, but I think in general, observability can be a bit of a bigger question. It's not only operational data, it can be any ways of understanding how your software is doing. I think the key thing that we've achieved is that we used to get questions at the start when I started off, oh, on my laptop I'm seeing that the website is doing this. And right now you can't really say that to anyone on Cinch because we know what's going on. You can quickly say, well, no, it's your laptop and you have a problem and everyone else is experiencing it fine. So you're in the 0.1001%. So we're not going to worry right now. So you get an idea what's going on quite quickly.
Gives you a lot of confidence. Yeah. You mentioned the data is customer centric. How do you use it to improve the user experience?
Good question. I think to an extent, it's more about the engineers being aware that the software is providing a service, and that service is either delivering or not based on indicators that you get. So the user experience, we still have UX people, and they're creative and they come up with good ways of looking at things, but it's with a funnel and with kind of knowing where people have errors or knowing where people have issues, that improves UX in itself by feeding back into the UXs, I guess. The on-call question is interesting.
I was going to say, feel free to consider that one off topic if you want, but
so if we have time, do we have time?
If time, if you want to answer it, yeah, if you'd like to.
So but, the on-call question is very it's very interesting. We're evolving that. We have in ours, the squads look after the production systems. We have people who support connecting dots, I guess, between teams and stakeholders and customer experience. But and that works well because they've got in ours rotas. It's not one person. We started being quite tough, right? Yeah, a tech lead would potentially look at all the instance, but now we're distributing that load and we're learning to manage instance. We run chaos days to learn how to manage instance properly. It's an art in itself. So, and we're looking into tooling in that space. Out of hours, we have a volunteered paid rota of engineers, and that's looking okay. To be honest, we don't have that many instances that require dealing out of hours, and that's an interesting observation in itself. We used to before our observability was rich, or before our system in general was mature. But if we do, we have these people who are able to respond.
Okay, I've got one more question if you want to take it. It's just popped up, but we'll call this the last one. How did you go about setting thresholds?
I presume that's around creating monitors on telemetry data. Thresholds are hard. It's one of the problems of monitors, and one of the promise that SLOs give, that service level objectives, that they allow you to contextualize things going wrong. We haven't really got there. We haven't really achieved using SLOs effectively. But yeah, monitors are creating thresholds are a bit. You kind of need a feel for it, and I think again, it's the teams. They know their data. If they interact with telemetry data often, they get a feel for it and they understand whether there's something wrong or not. It's not something that you set and forget. It's something that you continuously iterate over. So hopefully you get a feel of when something is bad or when something needs improving. And that's where the service level objectives that are kind of popularized by Google with error budgets and all that might help, but that's another big can of worms that is hard to fit in our heads, because it's yet another practice that we need to include in everything else we do.
Brilliant. Well, thank you very much. That was a great talk, and thanks for taking so many questions as well. I think you really you've added to what you've shared there with all those questions you answered. So thanks for all your insights.